expand 6p minus 9q raised to the power of 2. Solution. We have 6p minus 9q raised to the power of 2. Now, this is a perfect square, hence we can express this as 6p minus 9q into bracket, that same 6p minus 9q. Now, the next thing is to use the first term in the first binomial expression to multiply the whole of second binomial expression. So we have 6p multiplying 6p minus 9q. Now we use the second term in the first binomial expression, which is minus 9q, to multiply the whole of second binomial expression, which is 6p minus 9q. Now, the next thing is to expand the brackets. Now we use 6p to multiply 6p. 6 times 6, that is 36. So p times p, we have p squared. So it means that 6p times 6p will give us 36p squared. Now we use that same 6p to multiply minus 9q. 6 times minus 9 will give us minus 54. Now we have p times q, so we have minus 54pq as the second term. Now we multiply the second part of the algebraic expression. Minus 9q multiplied by 6p. What do we have? Minus 9 times 6 will give us minus 54. Then q times p, we have qp, which is the same thing as pq. Now, minus 9q multiplied by minus 9q. Minus 9 times minus 9 will give us plus 81, because minus times minus is plus, and 9 times 9 is 81. Now q times q will give us q squared. We have 4 terms in this algebraic expression, but 2 terms at the middle are like terms, so we need to add them together. So we have 36p cubed, 36p squared, then minus 54 minus 54 will give us minus 108. So minus 108. So it means that minus 54p cubed minus 54p cubed will give us minus 108p cubed, which represent the middle term. Then plus the last term, that will be 81q squared. That is the solution to the problem. Thank you.